So I'm going to try to give you examples to see how you can use the GPAC open source software to produce some media content that you can play in your web browser. So the first point is that the web browsers are more and more capable of playing media data. So you may have heard of the HTML5 audio, video, and track element, of course, but there is also JavaScript. So with JavaScript, you can do several things. So in combination with HTML5, you can use the extensions. So for example, media source extensions or encrypted media extensions, or you can use plain JavaScript to extend the capabilities of your web browsers. For example, if you don't know how to decode a certain codec, for example, data, you could imagine that you have a JavaScript decoder for data. And so we're going to explain the kind of initiative that we have taken inside the project to help you both on the server side and on the client side to produce some multimedia content. So maybe a few words about GPAC. GPAC is an open source software. It's licensed under LGPL, and now there is a commercial company called GPAC Licensing. But first it was started in 2000 as a startup in New York City. It's kind of a long story, but it's now hosted in a university in Paris. We are hosted on GitHub. It's rather new. We used to be on SourceForge, so we hope that there will be more comments, more issues, more pull requests, and it will make the process of using and contributing to GPAC smoother. It's cross-platform. It's a huge C code base, and we have several tools. We have tools from packaging, streaming, and playback, basically. I'm going to come back to this later. And one thing that is interesting is that our main packager, which is called MP4box, is also available as JavaScript, so mp4box.js. And it's really helpful when you need to provide some content to the browser, and the demuxer from the browser has different behaviors across browsers, or you can demux some kind of data, such as subtitles. Andreas Tai from IRT made a presentation this morning talking about subtitles. I think I have a slide later about this. And so we have packager, streamer, and a player. So this is an interactive player. The interface is made using SVG, and you can have many detailed information that are really useful. And this is one of the reasons why many industry actors chose to work with us when they needed to make demonstration like 4K 10 bits demonstration using the latest codecs, etc. Because they could get all the statistics. They could, for example, limit the bandwidth artificially and do these kind of things. Just a few words about the technologies, the video technologies that are used on the web. Initially, there was a lot of fragmentation. Like, we didn't know which codecs we were going to use, which containers we were going to use, and it seemed to have stabilized around the MPEG-4 technology. So the MP4 container, the MP4 video, AVC video, H.264, and some AAC MPEG-4 audio. So it really makes things easier. And one of the things about HTML5 is the addition of the audio and the video element. And if you consider the plain audio and video elements, you have to provide files to feed the data. And one of the extensions I've worked about in the second slide, which is called Media Source Extension, allow you to push some buffers of data directly to the decoder. And the way you get the data from the network is your responsibility. So you can use JavaScript to get the data, and you can feed the data to the browser media decoder. I think that Peer 5 is going to make a peer-to-peer demonstration at the end of the track later today. So one good thing is that it's supported by Chrome, the latest Internet Explorer. It's going to be added to Firefox. But there are some limitations, like you need to package your content in a certain way. So the good news is that with the tool that we provide with the packager, you can really simply take some content that you have packaged and transform it into something that makes it compatible with this latest technology. So if you need to mux some audio and video inside a file using MP4 box, you have this simple command line. And now if you want to make sure that your content will be compatible with the latest HTML5 extension, media source extensions, for example, because you need to switch the quality in the middle of the playback. For example, your content is available as a low quality playback for low bit rates and a high quality for high bit rates. For example, you can fragment your content, and at one point you can decide to send some other fragments from a different quality to the media decoder, and it's going to be seamless for the user. Another possibility for fragmentation is to use the Dash streaming technology that is going to be really popular. This is some adaptive streaming over HTTP. This is the new generation of protocols that are being deployed. So here is a command line where you can decide to dash your content. So here you have 1 second segments and fragments. And thanks to this, you can take advantage of the latest players, such as the Dash.js player that are freely available as free software on the web. Another subject, which is not really popular, so we had a talk this morning from Andreas Tai at IRT, is subtitles. And subtitles is quite a mining field because there is no agreement on the technology that we need to deploy. And the second point is it's not really easy to stream some subtitles. So we used to stream mainly pictures, and when we needed to split it, as I said, fragment it or segment it into small files that are being able to be streamed, it's not so easy. So this morning we saw that for the web there are two standards being standardized by the W3C. There is WebVTT and there is TTML. And there is a way to store them into the ISO-BMF, the MP4, the MP4 files. And actually MP4 Box supports both formats for the packaging. And in our player we have some partial support for WebVTT. We have no support for TTML, but there will probably be some way to translate TTML into WebVTT or WebVTT into TTML, depending on the need. Another interesting subject is encryption. So we're not going to talk about DRMs today. It's more about encryption. You want to encrypt your content for one reason or another. There is an extension of HTML5 which is called encrypted media extension that allows you to encrypt and decrypt the data. And what is interesting for us in our project, so we are experts in the MP4 file format. There is a technology which is called common encryption, and common encryption gives you the opportunity to separate the encryption itself, the key that is needed to decode the content, and the way the key can be retrieved. So this allows to share some audio and video files that support different protection schemes using the same files. So for example, if you need to have one protection scheme to play inside Internet Explorer and you need another protection scheme to play into Firefox, then you can have one single file that is going to be distributed to all the users. So it makes it really simpler. We support it mainly on the packaging side, that's the same. So we support a way to describe the different encryption scheme in a really standardized way, and it allows us to support different technologies such as Microsoft Play Ready, Adobe Access, Google Widevine, but also these are DRMs. But of course we support some other schemes that are really more simple and are just made so that if you make video one day, somebody will not make a right click to just make a copy of your content. And on the playback side, the GPAC player is quite limited, but there are some players that use the web players, such as Dash.js, but I'm sure that there's going to be some other players in the future to decode the content from the same content protection technologies, and I've given you the link so that if you're interested in this, you can see how to achieve this. Another project that I talked about is called mp4bug.js. So it gives you the opportunity to demax your ISO BMF file directly inside your browser using JavaScript. So we made it because manipulating MP4 files inside the browser was really complex. And when you give the file directly to the HTML5 video element, you had no control on it. And especially across browsers, you had files that you were able to play on some browsers and not able to play on some browsers. There are still many limitations. It's really experimental. So we give you the possibility to reassemble file on the fly. So I think that at the end of the track, there is Peer 5 that is going to talk to you about peer-to-peer application. So for example, gives you the opportunity to get a plain MP4 file that you would have encoded a long time ago, and you can get the different fragments from different places, and you can get them together directly inside your browser. So there is a page with a demonstration that shows you how it works, and you can play with it. Another subject, so I talked about the streaming of subtitles, but there is also the streaming of interactivity like SVG graphics. So this is a specialty of my colleague Cyril, who couldn't attend today. So it's the possibility to have some overlays, for example, to get some interactivity on top of an existing video, or simply to display subtitles. So SVG has been used when WebVTT and TTML were not already here, to have some graphical rich overlays, some text, etc. So you can see some examples. You can even play some cartoons. We have some cartoons in an SVG format. It's a really small format, and it's entirely scalable, so you can play it on small devices and a huge screen. One thing that is probably unrelated to the web technologies that I presented is called ZenBuild. It's kind of a new project that we have pushed on GitHub. Basically, one problem that we have is to build some of the our open source project like GPac. The player has many dependencies, and I think that it's true for FFmpeg, for libav, for VLC, for mPlayer, for many other open source players. And it was sometimes really hard to get a specific configuration of an open source software. Sometimes you have people saying, I need FFmpeg with the LGPL license, and I need support for free font, for example. And it was really hard to configure and to execute. So what we did is a component level build system. So it makes it really easy. You have a set of projects. You give the command lines to compile and cross-compile them. So there is a specific format. And from then you can decide to build them, and you can even generate subscripts so that you can then have a single script that will be able to generate this all. So we use it in GPac, and we're going to advertise it more during the year as we have more and more modules, so that people can build FFmpeg, GPac, or whatever project more easily. Another thing is to have, Kieran this morning said we have no equivalent of LAMP in the multimedia field, and maybe there is UPipe, which is a start. We are also working on something similar with probably for different reasons, and we are trying to find a way for people to build easily multimedia applications, whether they are inside a single process, several processes, across different computers, and to make it really easy. So it must be easy to write some applications, but also to write some components. So for example, there are some people who want to add some support for AV synth, or just think about it as a piping system, but probably with things that will allow you to do advanced things such as scalable codecs, etc. So actually, it's not. It's going to be open source. So I expect it to be open source in 2015. And what is interesting is that it's been entirely financed by the industry. Um, so actually, people were looking for different applications, like a player in a TV or cloud transcoder, etc. And that's how we did it. So the last slide, just to present you the different subjects we're working on, what we're going to do this year, and the kind of demonstration that we're going to show. So the first one is relative to scalable codecs. So for the HEVC decoding, we've been working closely with the team from OpenHEVC, and that's how we did mini demonstration, like 4K demonstration, 10-bit video demonstration, higher frame rates, etc. And we believe that scalable codecs like SHVC, so the scalable version of HEVC, could take off somehow, and especially with some hybrid delivery, like HBBTV or these kind of things. So people would receive, for example, a standard definition version of the content, and if they pay for the bandwidth, they can get the complement so that they can receive with the 4K, or they can receive an additional whatever. It could be an additional audio or whatever. And in terms of ISO-BMF, so the MP4 file format, in terms of ISO-BMF signaling, this is really not trivial. So we're working on it. Another thing that we'd like to work on is the storage of Opus. So there is a specification of Opus in MP4, in ISO-BMF, which is being written, and we hope that we can help on this. The other thing is the storage of images in general. So this is related to subtitles, this is related to radio, this is related to many things that are not purely video. Another thing is related to MPEG-Dash. So I talked about MPEG-Dash. The adaptive streaming over HTTP is currently a hot subject. So there is the Dash Industry Forum, there is HBBTV, so TV, interactive TV, and there is the streaming of subtitles. Another thing that we implemented in GPAC is WebRTC. So actually, a trainee spent 6 months on this, and we hope to be able to use GPAC as a WebRTC peer. So the aim is to use it as a peer, and I think that for some projects such as peer-to-peer delivery, it's going to be useful. And the other project that I presented to you, so ZenBuild, so that you can build easily your multimedia open source project, and Signals, so that people can build more easily their streaming applications. Thank you.
So we have plenty of time for questions. So other questions or remarks? Yeah, please.
Your plugin is dead, or it's an old project that you don't do? You used to have a plugin, I don't know the name.
So we used to have a plugin for web browsers,
Yeah.
like Mozilla, and yeah, actually, so that's true. We so Osmo 4 is the name of the Windows player. We have Osmozilla, which is a plugin, an NP API plugin, so it works in Safari, in Firefox. It's going to work for a few weeks in Chrome, since Chrome is going to deprecate totally NP API. So yeah, it's not abandoned. It's just, it's open source. Someone did it at one point, and actually we don't use it. So users, need to make requests if something is broken. Actually, we don't believe in plugins. We think that HTML5 is going to take over. And so we need to adapt, and that's one of the reasons why we played with the Mscripton. We decided to release this version of MP4Box, which is called mp4box.js. And we think that the people doing the player, like GW player, dash.js, etc., they are going to be better than we are to make a player inside the web browser. The other thing that I didn't say is that the GPAC player has some HTML5 capability. Like, we have some JavaScript, we support some of the HTML5 video elements, we support media source extensions, so possibly we could extend it at one point if people are interested to have a lightweight player that would support these kind of things. And I know that at one point we tried to port the Dash.js player directly inside GPack. So it would be really lightweight, and you wouldn't have to deploy a full web browser to play your content inside the browser.
Yes, question from Andreas.
Yeah, first thanks for the very interesting talk. So very question regarding the Robot.js and the exponent label for meters of extension. So we tested already in Robot.js for maximum dash segments with subtypes, HTML, and it works just fine. So the question for dash WebVDT is if you do use in Robot.js and make it available over media source extension, could you use the native WebVDT rendering from the browser?
Okay, so the question is related to mp4box.js and subtitling. So if we extract the data, the WebVTT from mp4box.js, yes, you can use the native rendering from the web browser. Yes.
Okay. So this should then already work with the
Yes, sure. There is no link on this, but Cyril Concolato, my colleague, made some experiments and he put the result on his blog. Yes. If you have a question, just ask him because he's the expert in these kind of things.
Other questions? I have a question to you.
There-
Rita.
What's the difference between your JavaScript implementation of Dash client with the official JavaScript Dash client?
Okay, so the question is, what is the difference between our JavaScript implementation of the Dash client compared to the Dash Industry Forum Dash client? We don't have a Dash client in GPack in JavaScript. Our Dash client is a native application, and we aim to use our demuxer, for example, plugged inside the Dash.js player. Because, for example, there are some files that don't play in Dash.js, and people don't know why. So they all use the same command lines, and they are really limited in the set of features that they can use from the ISO BMF container. I think that everybody who tried this got into the problem like media source not found, which is one of the error of Chrome. There are 2 error messages anyway in Chrome when you have issues. So everybody's using the same functionalities, and we're really limited right now in the web players. That's one of the reasons why so many people like the Bitmoving company with their BitDash player. They have a Flash version which is really more extended, and when they don't know how to play a content, they switch back to the Flash version of the player. So we're still limited.
I had a question regarding the licensing. You said GPack licensing. Is there special licensing you are applying for your developments?
Okay, so the question is about the licensing of GPack and the commercial initiative called GPack licensing. So what happens is we contacted all the copyright holder, and they signed an agreement saying that they agreed that the code would be sold. So it acts as a cooperative, actually. So we can relicense the code. This happens, for example, with our LGPL, and when people want to use GPack inside their iOS application, you know that they can't distribute dynamic library. So in fact, they would violate the license. So they buy a license for us, and it's easier for them.
So you do sort of dual licensing. So it means
Yes, it's dual
every
licenses.
contributor to your project has to give the copyright to you.
Yeah, possibly every contributor has to sign a CLA. That's right.
Last question?
Yeah, and just one question regarding the perspective of Dash. So you say it's a hot topic and there's a lot of talk and there's some work ongoing. But how do you see the market adoption? So you see the content using Dash. How do you see the content provider side using Dash?
Okay, so political question. How do I see the diffusion of Dash in the future? I'm going that Dash is really going to take off. There are many actors from the industry pushing really hard. And right now we have HLS, which is going to be supported in Windows 10, which is probably going to be extended to the new HEVC codec. So it's not going to disappear, But at the same time, we see the problem is Apple, and at the same time, we see that Apple, their content protection scheme with AES is not sufficient for majors. So actually, Safari has some support for Dash, as you've heard of. So I think that Dash is really going to take off.
Okay. So we'll conclude the presentation now. So thank you very much, Romain.